In this video, we will solve question number 41 from GATE 2020 chemistry paper. Now the question is the following. The hydrogen-like radial wave function of the 3s orbital is given here, where rho is the 2zr divided by a0, where z is the atomic number, r is the distance from the nucleus, and a0 is the Bohr radius. Now we have to find the position of the radial node in the units of a0. Now these four options are given here. Now before answering this, let's first look at some of the background. So an orbital is basically an one electron wave function, and for atomic orbitals the wave function can be separated into a radial part and an angular part. Now let's say this capital Psi is an atomic orbital wave function. Now in three-dimensional polar coordinate, this psi is a function of r, theta and phi. R varies from 0 to infinity, theta r varies from 0 to infinity, theta varies from 0 to pi, and phi varies from 0 to 2 pi. Now this psi can be separated into a radial part and an angular part. Here r as a function of r is the radial part, and capital Y as a function of theta and phi is the angular part. Now the radial part of the atomic orbital wave function defines the size of the orbital as a function of r. That means the size of the orbital as a function of distance from the nucleus. And the angular part of the wave function defines the orientation of the orbital in space. Now let's understand the concept of nodes. The nodal points or nodes are the points where the phase or the sign of the wave function changes, and at the position of nodes the wave function, the atomic orbital wave function capital Psi, equal to 0. That means the modulus of psi square, which is the probability density, that means the probability of finding an electron at the nodal points, is also 0. Now this question is about finding the position of radial nodes. So what is radial node? The radial nodes or radial nodal points are basically the points where the radial part of the wave function, that means the capital R as a function of R, becomes 0. Now the radial node basically consists of spheres. This is the schematic representation of 2s orbital in 3D space, and this is the cut-away view. Like if you cut in the middle, cut through the middle of the 2s orbital, so this is the view. Now if you look close enough, this point, this center point, the origin is the nucleus. Now if you go further away from the nucleus, like at a certain distance from the nucleus, the probability of finding the electron, that means the probability density, is getting higher. That is the red region. Then the probability also decreasing. That means the red transition from the red to white region. Then also after a certain at a certain distance from the nucleus, the probability of finding an electron is also increasing. That means the red region here. So that means at a certain distance from the nucleus, the probability of finding an electron becomes 0. That means this white region here. Probability of finding electrons becomes 0. So this is the position of radial node for the 2s orbital. Now this is the schematic representation of the 3p orbital, that means 2px, 2py and the 2pz orbital. Here principal quantum number n equal to 2, and for these 3 orbitals there are no radial nodes, there are nodal planes here, so these are the angular nodes. Now what is the formula or what is the expression for computing the number of radial nodes in a particular orbital? So this is the expression, which is the n minus l minus 1, where n is the principal quantum number, l is the azimuthal quantum number, and we are subtracting this 1 here because at the infinity, that means at very large distance away from the nucleus, the wave function becomes eventually or asymptotically becomes 0. That means the probability of finding an electron at very large distance from the nucleus is asymptotically becomes 0. So we will not count the position at infinity as a position of radial node. So that's why we are subtracting this minus 1. Now let's calculate the number of radial nodes for the 3s orbital. So for the 3s orbital, we know n equal to 3, and for s orbital, l equal to 0. So n minus l minus 1, that means 3 minus 0 minus 1 equal to 2. So for 3s orbital, there will be 2 radial nodes. Now let's look at this picture here. So this is the plot of radial distribution function, in short RDF, which is the full form of radial distribution function, as a function of r, which is the distance from the nucleus. Now if we look close enough, there are 2 points at these points, or at this distance from the nucleus. The radial distribution function becomes 0. That means these are the position of nodes, radial nodes. So there are 2 radial nodes for the 3s orbital, which is clearly visible. And also at infinity, that is very far away from the nucleus, the radial distribution function becomes asymptotically 0. But we will not count the position infinity as a position of radial node. Now let's calculate the position of the radial node. Let's locate the position of the radial nodes. So as we have seen in the previous slides, at the position of radial node, the radial part of the wave function, that means the capital R, equal to 0. Now the expression of capital R for the 3s orbital is given here, given in the question. So this is equal to 0. Now from this equation, either this part will be equal to 0 or this part will be equal to 0. Now from this part, like exponential minus rho divided by 6 equal to 0, from this part we can get rho tends to infinity. Rho tends to infinity, but as we have said in the previous slides, that the infinity position will not be counted as a position of radial node. So this point is excluded. Now from this part, 6 minus 2 rho plus rho square divided by 9 equal to 0. But after rearranging this, we can get rho square minus 18 rho plus 54 equal to 0. Now we can compare this with this type of expression, like ax square plus bx plus c equal to 0, where a, b, c are the coefficients and x is the variable. So we can solve this type of equation by using x equal to plus minus x equal to minus b plus minus root over of b square minus 4ac divided by 2a. So we can use this expression to solve this equation, where rho equal to minus b means minus of minus 18 plus minus root over of b square means minus 18 square minus 4ac, 4 times 54 times 1 divided by 2 times 1. So we can get rho equal to 9 plus minus 3 root 3. Now we know that the expression of rho is the rho equal to 2zr divided by a0. So r equal to, after rearranging this, we can get rho times rho a0 divided by 2z. So r equal to 9 plus 3 root 3 divided by 2z a0, or the 9 minus 3 root 3 divided by 2z a0. Now the question is about finding the position of radial nodes in the units of a0. So the answer will be option C, because the option C says 9 plus 3 root 3 divided by 2z and 9 minus 3 root 3 divided by 2z. So this is the correct option. Now for further details you can visit the following NPTEL reference. This is the NPTEL lecture series on the topic of quantum chemistry of atoms and molecules. The instructor is Professor Anindya Datta from IIT Bombay. Thank you.